The reflected light from the moon has its origin in our star, the sun. Stars illuminate the universe. They are the source of the light that bathes the planets. But the processes by which light is emitted by the stars can be explored here on Earth. On the 31st of August 2014, a vast chasm opened up in central Iceland. At its peak, the Bardarbunga volcano spewed out 350 cubic meters of molten rock every second. Producing light so bright it could be seen from space. And just like the sun, lava glows because it's hot.
Just look at that. It's many months since the eruption, but it's steaming away back there. We're actually fortunate that it erupted here. The helicopter pilot told me that if it erupted on the glacier, then we would have been plunged into a perpetual nuclear winter and civilization would have been destroyed. It's not actually quite right, but it would have been significantly worse. The amount of ash that went up into the atmosphere would have been really considerable. You get a sense of the power and violence of the Earth, because we're blissfully unaware of it usually. When it breaks through the surface, you see what it can do.
Today, the lava has cooled into matte black rock, but it's still giving off light. But the thing is, everything's hot. Everything has a temperature. But if it's cold, it just emits light that we can't see. This camera can see it though. It's called infrared light. You see there that this lava is glowing brighter than the background. That means it's hotter. So, although we can't see it, everything shines. Light fills the universe. Radio waves are light, X-rays are light. Visible light is simply the part of the spectrum we can see. Matter, like lava, or you and me, is made up of electrically charged particles. Here's one, moving along. Let's say it's an electron. Temperature is a measure of how fast those particles are moving around, how fast they're jiggling. So in something hot, these particles are always bouncing around and changing direction. Now here's a fundamental law of the universe. When a charged particle changes direction, it emits light. A particle called a photon. Light can be thought of as a stream of photons, particles whose energy corresponds to their colour. Cooler things like solid black lava emit lower energy photons, infrared light, which our eyes can't detect. As things get hotter, they can radiate higher energy photons. At 1,000 degrees Celsius, molten lava shines with mainly red light, which our eyes can detect. The surface of the sun is 5,500 degrees Celsius, so it can also produce higher energy green and blue photons alongside the red.
The white light of the sun is made up of all the colours of the rainbow. And when it reaches the Earth, those individual colours are revealed.
Photons from the sun rain down and enter water droplets. They reflect off the rear face, out of the front again and into your eye. But the blue photons, the higher energy ones, behave differently to the green ones and the yellow ones and the red ones. They come out at a shallower angle, and that's why you get the full spectrum of colours from the white light of the sun.
And it's this light that paints the Earth. The colours of our planet arise because of the way photons from the sun interact with the matter